Jim White. So I like, I was going to say good editors. I'll just call it pretty editors. So I'm a Jupyter Notebook fiend. In fact, I made my own version of notebooks before they were cool. Um, uh, and so, and for the things that LLMs are terrible about, computer languages, logic systems are good at. ACL2, a computational logic for applicative common Lisp, is the most industrial strength prover system in existence. Has been used to prove the correctness of many, many systems. VLSI, famously, the first commercial application in chips was instigated by somebody who's talking about Intel's failures, was the great Intel FDiv bug of 1991, which led AMD to call the guys over at Austin to have ACL2 used to prove the correctness of the floating point unit in the AMD processors. That became the first mathematically proven correct FPU unit, and that was used in ACL2. And it's gone on. There's many machines have been verified using ACL2. And just last fall, there's a simulator called Y86, which is basic x86 simulation. It's been around for a long time. As of last year, it is able now to boot Arch Linux. There's also a subset of ACL2 called Milliwa, which is a theorem prover in ACL2, including its compiler to MIPS, PowerPC, showing how old it is, and x86. So it's now actually possible to run a complete prover in the operating system that's verified correct, or at least performing to your logical specifications, if you believe them. But anyhow, this was a lot of digression to talk about. So ACL2 Jupyter, this is a Docker image, including dev container, with some instructions for a variety of different ways to run it. It's multi-architecture, runs on your Mac, it runs on any Intel. It also, what it's showing here is you can run it with the dev container, you can run it in code spaces. And there are some links to other resources, one of which is this set of example notebooks, which were done by a guy named Mike Dodd, who works for Galloy. And he asked Claude Code to update the intro notebooks or intro code of Coke to for the natural numbers, this kind of stuff. Can Claude Code write ACL2 just from referring to the code? And it did, and it wrote this. And what you get is this perfectly lovely ACL2, including comments and things like this. But what does this do, right? So that's why notebooks, which bring literate programming to all of your languages, and it's especially important if you to have literate programming when you're doing proofs, because you want to see what the heck does this do, and also is it actually true, right? Because you just be able to click and see once it's been proven. So the way you can see this is like these instructions. I've already hot loaded this, so it's going to go much faster than it would if you do it from scratch. But basically you just do new code space, you point it at your repo, it'll start it, and it'll launch it into VS Code. Obviously, don't use that. You just come down here, open a Jupyter Lab, is in preview, works fine. And again, this takes a little bit to do. From scratch, it takes a few minutes because this image is over 6 gigs. But so not as quickly as this, you will get this this lovely desktop, which also, even more on topic, includes SBCL as part of the package. Z3 is in here. And I didn't want to do that one. And I was going to show you these examples. Whoops, not that one, this one. And it just works. You can, you know, there was a lot of demonstrations. Does this really compute? Run all the cells. And part of what's going on in here is, like, for example, here is referring to another book. And in order to include a book in ACL2, it needs to have been proven correct before this. If it wasn't, this would fail. And in fact, if you just did this sequence without having the other certification files be in there, it would say, hey, dude, you need to prove this stuff. And there's a make file for that, and which is a whole bunch of things, including make certify, which will go and certify all the books. So check it out. Love to know if you have any luck or experience or things like this, but ACL2-kernel. Actually, this is the back. Whatever. Thanks.
Any questions on that? I just have a comment. I saw, it hasn't followed. I saw wording of that. That was, and I'm going to say the same thing to you that I said. I didn't have to talk about it. That's awesome, right? I think what you're doing here is awesome.
Well, please do, because so I spent having a group last year. We had a weekly on TDD, and also my friend Ray Myers, who's now the chief architect for All Hands, the Open Hands coding agent. And he had, at the beginning of the year, declared 2024 the year of formal methods. And he didn't know how correct he was, because after I kind of assumed that there surely had to be something better today than ACL2, which is this old Lispy thing, which nobody wants to use. And after trying all the other provers, no, they're not. If you actually want to prove programs correct, ACL2 crushes them all. And it has been, it's, as I say, unprompted. If you ask GPT or whoever, what's ACL2? It's an industrial strength theorem prover because it's used to run, has been already run on large systems. And this was done when machines were slow.
I've been trying to figure out how to use leans to do this.
Well, and so lean's a great example. So this is kind of my litmus test. One of the examples in the ACL2 Docker one is Quine. And if you ask ChatGPT to write Quine and lean 4, it'll say you can't do that. You'll say, well, what do you mean? It's like, oh, well, you have to use the meta language. And so you can write a program that does the proof, the mathematical part of the proof in lean, but you have to use the meta language to convert the lean text into the representation. And there's no proof for that. It's in Go or something like this, right? Yeah, ACL2. So if you're going to do computational proofs, the first thing, my litmus test is, show me that you can do a Quine. That way I know I won't run into a roadblock, because what I'm after is having evolving self-reflective systems that Douglas Hofstadter and Doug Glenat are my inspirational heroes. Somebody was talking about how the old guys feel about now that, intelligence has been cracked and natural language has been cracked. Hinton, and Hofstadter, and also Dennett, these guys are all crushed, and Hofstadter's talked a lot about how he feels emotionally just wrecked, that the problem turned out to be so easy that it got done in his lifetime. I don't see Sapiens as the peak of anything, right? And being up a Neanderthal, I have, very mixed feelings about this whole Sapiens thing. So no, we're not the peak of evolution.